Welcome to the deep dive. Today, we're going to be exploring something kind of counterintuitive. Is scientific progress actually slowing down? I mean, we have more researchers than ever, journals are overflowing with new studies, but some evidence suggests we're not seeing as many groundbreaking discoveries as we did maybe like a few decades ago.
Right.
So you might be thinking, why should I care about this? Well, a slowdown in science could have huge implications for a lot of things, tackling climate change to curing diseases, things that affect us all.
Yeah. Definitely.
This whole thing has really puzzled a lot of people, right? Especially when you think about how much money and effort we're putting into research.
Yeah, it really is kind of a head scratcher, especially when you look at all the data. Economists actually use this concept called total factor productivity
Hmm.
to measure, how efficient we are at turning inputs like funding and scientists into outputs like new technologies.
Oh, that's interesting. So kind of like if you're baking a cake,
Yeah.
you'd expect more bakers and more flour to make more cakes.
Oh, yeah.
But what we're seeing is that even with more ingredients in science, the number of groundbreaking cakes, the like revolutionary discoveries, hasn't increased at the same rate.
Yeah, that's a great analogy.
Oh.
And it really highlights this trend that, the research output just hasn't kept pace with the amount of investment.
So we're getting less bang for our buck when it comes to truly transformative innovations.
Unfortunately, it seems that way.
Now, the source we're diving into today actually has some really specific evidence about this. For example, they talked about this study that analyzed tons of patents
Oh, wow.
and found that the rate of disruptive innovations, the ones that completely changed the game, has significantly declined since the 1960s.
It's fascinating because they were actually able to quantify it. Patents these days are much more likely to just be, small improvements on existing tech instead of these radical new concepts. It's like we've gone from inventing the wheel to just making slightly better tires.
They had this really great example, the invention of synthetic fertilizer back in the early 20th century. Like
Right.
that single innovation that completely revolutionized agriculture
Really did, yeah.
and had this massive impact on global food production, a real game changer. But, we don't really see those kinds of discoveries happening as often anymore.
It's true. And, a lot of the fundamental technologies that we rely on, like the internet, antibiotics, nuclear energy, those breakthroughs came decades ago. Now it feels like so much research is building on those foundations instead of making those big leaps forward.
Right, so are we just like living off of the scientific capital from a more innovative era?
Hmm. That's a great question, and it's one that a lot of researchers are struggling with. But yeah, it does seem like we might be entering an era of diminishing returns, at
Yeah.
least for those really disruptive breakthroughs.
So it's not all sunshine and roses, huh? But the source doesn't just stop at pointing out the problem, right?
Right.
They actually dive into some possible root causes within the way that we actually do research today. And one of the things they point to is all the bureaucracy and academia and research institutions.
Yeah. And a lot of researchers really feel this, like all the red tape. The source actually even uses SpaceX as an example. SpaceX is known for being super innovative, right?
Right.
But even they face a ton of red tape and regulations.
Oh, wow. So it's like trying to launch a rocket while being stuck in quicksand.
Yeah, basically.
Isn't
And
that
it's not just SpaceX. So many researchers know now where their field, they're spending more and more time dealing with admin stuff, applying for grants, and complying with all these regulations. It just leaves way less time for the actual research.
right? That makes sense. But is bureaucracy the only problem here? The source also mentions this publish or perish culture in academia.
Ah, yes.
I've definitely heard of it, but I'm not really sure what it means for science.
So publish or perish basically means researchers are under all this pressure to constantly be publishing their papers
Okay.
to, advance their careers, get funding, and sometimes even keep their jobs. It's this never-ending race to publish, and a lot of times it means sacrificing quality for quantity.
Wow. So instead of focusing on a few high quality, impactful studies, they're just churning out smaller, less significant papers to like stay afloat.
Yeah, that is kind of the unfortunate reality in many cases. And that focus on quantity over quality can actually slow down progress. It dilutes the research pool and makes it much harder to find those truly important discoveries.
Right. That makes sense. And then on top of all of that, there's also this growing culture of risk aversion.
Oh, definitely.
It seems like it's safer to stick to projects that are probably going to get funded, even if they're not that innovative or groundbreaking.
It's much easier to get money for research that builds on what we already know or solves a well-defined problem. But to go after those really radical ideas, the ones that could revolutionize things, those are riskier and much less likely to get funded.
So the system is almost working against the research that could lead to those big leaps forward.
It seems that way, yeah. But the source also talks about public versus private research and how each one has a different role in fostering innovation.
Right. I'm curious to hear more about that.
So private companies, they're focused on profits.
Right.
So they're much more likely to invest in research that has immediate commercial applications. That's great for new products and technologies, but they're way less likely to take on the kind of long-term, high-risk research that might not have a payoff for years.
So that's where publicly funded research comes in, like
Exactly.
the research at universities and government labs.
Exactly. Public funding is crucial for those foundational projects,
Right.
the ones that could lead to entirely new fields of study, even if it takes a long time and there's a lot of risk involved.
Yeah.
And that's something that private companies just might not be able to, stomach.
But are universities and research institutions actually equipped to handle this role? With all of the inefficiencies that we've been talking about. The source actually mentions this issue of misallocated research funds.
Oh, yeah.
They even give an example of what some people might call a frivolous study, like researching the effects of airport noise on hermit crabs.
Yeah.
I mean, how is that going to help cure cancer?
I think it's important to remember that, not every single study is going to lead to this massive breakthrough.
Right.
But exploring those, niche topics can sometimes lead to surprising things or even spark new areas of research. However, it does bring up the question of whether all of the money is going towards the most important things.
Right. So if people see their tax dollars funding research, that seems kind of pointless.
Yeah,
It's going to make them less likely to support science.
definitely. Public trust is super important for continued funding and support for science. And when people think that research is wasteful or out of touch with the real world, it just erodes that trust. And that's something that scientists really need to be aware of, especially these days when misinformation and skepticism about science is on the rise.
But it's not just public perception.
Right.
The source also mentions that a lot of researchers are feeling disillusioned.
Yeah, definitely.
Like they're frustrated by all the bureaucracy, the pressure to publish all the time, and the lack of support for truly innovative ideas. It seems like the system is burning out the very people who should be driving progress.
It's a big concern. We're actually seeing a lot of talented researchers leave academia.
Really?
Yeah, or even leave science altogether because they're just so disillusioned. They feel like they can't be creative and their passion for discovery is just gone, overshadowed by the constant need for grants and publications and all the administrative burdens.
So we've got this system that might be preventing big breakthroughs, which leads to less public trust, and even the researchers themselves are feeling discouraged. It's kind of a bleak picture.
Yeah, it is concerning. And the thing that makes it even more urgent is that scientific progress is so important for tackling the biggest challenges that we're facing. I mean, we're talking about climate change, pandemics, not having enough resources. We need innovative solutions to build a future that's sustainable.
Yeah, the stakes are pretty high. But before we go too far down that road, let's talk more about these societal stakes and explore what we can do to turn things around. We'll do that after this short break.
Yeah, it's easy to, focus on all of the challenges, but at least we're talking about it.
Yeah.
Right? That's the first step to actually finding some solutions.
Right. I mean, acknowledging these problems is super important. So
Definitely.
what do we do? Like, if the system itself is kind of the problem,
Hmm.
how do we fix it?
Well, there's no easy answer.
Yeah.
But I think if we focus on a few key things, it could really make a difference.
Okay, what kind of things?
Well, first, we need to tackle all of that bureaucracy we talked about. Like, we need to simplify all the admin stuff, reduce all the paperwork, and just give these researchers more time to do research.
Okay, so basically clear the runway so those scientific rockets can actually take off.
Exactly. It's about getting the most out of our investments in science. But if we're spending all of this money, we need to make sure it's actually helping make new discoveries.
Right, less bureaucracy, more efficiency. What else?
We need to totally rethink this whole publish or perish thing.
Oh, yeah.
Instead of pushing for quantity, we should reward quality,
Yeah.
impact, and, maybe even failure.
Wait, rewarding failure? I don't really get it.
Uh-huh. Okay.
Yeah.
Yeah, I know it sounds kind of weird.
Yeah.
But think about it. Not every single research project is going to lead to this big discovery.
Sure.
And a lot of times the most valuable lessons actually come from the experiments that don't work out. We should create a culture where researchers aren't afraid to take risks, try new things, and yeah, even fail. I mean, that's often where the biggest breakthroughs come from.
Okay, yeah, that makes sense, but how do we get there?
It's about shifting from being afraid to fail
Mm-hmm.
to seeing it as an important part of the process.
Right, like a stepping stone.
Yeah. And that's where funding comes in. We need to fund those high-risk, high-reward projects, even if they take a long time or we don't know what the payoff is going to be.
So kind of like venture capital, but for science.
Yes, exactly. Invest in lots of ideas knowing that some will fail, but the ones that succeed could have a huge impact.
That makes sense, but wouldn't private companies be all over that?
Well, not really,
Why not?
because companies are so focused on profits, they're probably going to be hesitant to take on those kinds of projects, but the government can and should do it. It's about investing in the future, even if the returns are way down the road.
That makes you wonder if there are examples of publicly funded research that's actually led to, like, huge discoveries.
Oh yeah, totally. Think about the Human Genome Project.
Right.
It was huge and publicly funded. It was risky and took a long time, but it completely revolutionized genetics. Or the early days of the internet.
Oh, wow. Yeah.
That was mostly funded by government agencies.
Wow.
It was a gamble, but I mean, look at it now.
Yeah, that's a great point. Okay, so we need more support for high-risk research, get rid of this whole publish or perish thing, and recognize how important public funding is.
Right.
But let's be real. I mean, shifting the entire research system is a huge task.
Yeah, definitely.
And where do we even start?
Well, I think a few things can help. Like, we need more funding opportunities for high-risk research.
Oh, okay.
Those venture capital for science things that we talked about.
Right, like specific grant programs or funding agencies that are looking for those really out there ideas.
Exactly. And we should be supporting young researchers more.
Oh, yeah, because they're the ones with the newest ideas and ways of looking at things.
Right. We need to encourage those innovators and give them what they need to go after those big ideas. And another important thing is collaborating more.
What do you mean?
Like researchers from different fields working together.
Okay.
Because some of the coolest breakthroughs happen when you bring people from different fields together with their own expertise. It's like, got to break down those walls between the different fields and encourage people to work together.
Like cross-pollinating ideas, that's awesome.
Right.
But we can't leave out the public.
Definitely not.
I mean, public support is so important for funding and making sure that research actually aligns with what society needs.
Right. We have to do a better job at showing the value of science to everyone, explaining not just what we're doing, but why it matters. We need to highlight all those amazing things that science has given us, from life-saving treatments to all the tech that we use every day.
So we need to not only show how cool science is,
Right.
but also be really transparent about the whole process, the good and the bad and what we're really working towards.
Yeah, we have to build trust with the public. But that also means being honest about the reality of it. Not every study is going to lead to a cure or some new technology. But every discovery we make, big or small, adds to what we know and can help make new breakthroughs in the future.
And I think we also need to inspire the next generation, show young people that science is really cool, rewarding, and incredibly important. We need to get them excited about science so they can be those future innovators and problem solvers.
I agree. We need to encourage that curiosity and passion for discovery. So in the end, inspiring that next generation, creating a culture where people aren't afraid to take risks, and making sure we invest in the future of science, those are the things we need to do.
It's amazing how we've shifted from, like, kind of a negative outlook to something a little more hopeful.
Yeah, I agree.
It's really nice to think that we can actually make a difference.
Yeah, we can get stuck in the problems, but we can change things. We can invest in innovation, support research, and create a culture that values science. It's not going to be easy, but it's really important.
You mentioned before that this whole slowdown could hurt our ability to tackle those really big challenges that we're all facing, like climate change. Can you explain more about that?
Sure. So we've got things like climate change, pandemics, resources running out, all these things that could threaten our very existence. These are really complex problems that need some serious innovation to fix. If science slows down, if we stop making those breakthroughs, our ability to deal with these things is going to be really limited.
So we're not just talking about missing out on new gadgets.
Yeah.
This is about survival.
Yeah, science isn't about making our lives easier. It's about making sure that humans can survive and even thrive on this planet, especially with all the challenges we're facing.
Right. So it really puts things in perspective and makes this whole conversation even more important. It's like a wake-up call
Yeah,
that we all need to recognize how important science is and support it.
I couldn't agree more. Our planet, and maybe even humanity, depends on it.
Yeah, it really is a sobering thought. The idea that science might be slowing down right when we need it the most. but at least this hasn't been like all doom and gloom.
True.
We've talked about some really cool ideas about, how to get science back on track, but I keep thinking about what you said earlier about how we really need to understand these problems if we're entering an era of diminishing returns.
Absolutely. We have to be having these conversations, not just scientists, but like everyone. If we want science to keep solving these big problems and help create a better future, we have to be a part of it.
Okay, so let's talk to our listeners, the people who are listening to this right now. What can they actually do to support science?
Well, I think the first thing is to just stay informed. Read articles about new discoveries, talk about the problems that science is facing, and be aware of the things that affect funding. Basically, be an informed citizen.
And use that knowledge to advocate for science.
Yeah, exactly. And don't think that you can't make a difference. You can support your local universities and research institutions, go to events, or volunteer for groups that are trying to teach people about science. Even just encouraging a kid who is interested in science can have a huge impact.
I love that. It's all about creating a culture where we value and appreciate science.
Absolutely.
So to wrap up this deep dive into whether scientific progress is actually slowing down, I think the big takeaway is that even though we've seen some worrying trends, there are solutions and we can be a part of that change.
I think if we really are in a time where those huge revolutionary breakthroughs are going to be less common, then it's even more important to ask ourselves how we can support research that leads to those discoveries. How do we create a system that's all about innovation and taking risks? And how to make sure that science keeps making the world a better place?
Those are really great questions that we should all be thinking about. Thank you so much for joining us on this deep dive. Until next time, stay curious, keep learning, and never stop asking the big questions.